All right, 39 is kind of tricky. But referring back to problem 27, you'll remember that when we did implicit differentiation, we got to this point. And now that we know that we want to set y prime equal to 0, we don't have to expand the entire left side of the equation. We can just substitute for y prime right now, and this term will drop out, and this term will drop out, and we'll be left with 8x cubed plus 8 xy squared equals 50x. And yes, x equals 0 is a solution to this equation, but clearly when you look at the curve, there's two tangents and they're neither one horizontal, so we'll cross that off. That means we can divide through by 8x, and we're left with x squared plus y squared equals 50 divided by 8, which is 6.25. So that means that x squared plus y squared equals 6.25. We can go back and substitute that into the original equation, and we get 2 times 6.25 squared equals 25 times x squared minus y squared. Well, y squared from here, y squared equals 6.25 minus x squared. So this would be x squared minus 6.25 plus x squared. And let's see, when you multiply all of this out, I got 78.125 on the left, and then this is 50x squared minus, I got 156.25, and so 50x squared, I got that equals 235.375, and x squared equals 4.6875. I'm not sure. It seems like I've done everything right here. But anyway, so x equals the square root of 4.6875, and then you could plug that in and solve for y. This, of course, would be plus or minus the square root, and then when you plug this in for x, you'll eventually come out with probably an expression such that y squared equals some number over here, so y would equal plus or minus the square root of that number. And that would give you 4 points, and you can see on the curve that they're almost, there certainly are 4 points where the tangent's horizontal. So I'm not sure if this number is correct. It's kind of an odd number, but the general methodology, I think, is correct.